Hi, friends. Good morning. Thank you so much for being here. It means everything. The folks who showed up to listen to us talk. There's a lot of great talks, and you could be here, and that's awesome. So thank you. Taras, come on stage, man. You're the peanut butter to my jelly. You've got to be here. So we're going to tell a story about a very chance encounter that happened last year in Palo Alto, California, where I was having dinner with some Ukrainians who were here on a trip from U.S. Department of Commerce to do investigations into obtaining transformers or upgrades to their electric grid. This would be in March of, well, everyone is familiar when the full invasion happened in 2022 of February. We're all aware, at least partially aware of, the Russian aggression and the attacks on critical infrastructure, substations being destroyed, transformers being destroyed, making it very difficult to distribute power inside of Ukraine. And they were on a shopping mission just to see what the market had and what solutions they could innovate and be creative with. And I was invited to dinner through some contacts at Cisco, and it was just dumb luck that one of the things that they happened to mention, of course, I'm a power and cybersecurity expert, so I'm very interested in what's going on in Ukraine. And basically, they took my very annoying questions and just shared with me so many problems they were having. And they mentioned one thing specifically about GPS timing. And before we go too far, it's really important that you understand what Ukrenergo does for Ukraine and what currently the situation in Ukraine for critical infrastructure is. And then I will sort of pick up the second half of that story. So without further ado, I want to introduce my friend Taras. Please introduce yourself, sir, and I'm just going to hang out.
Hello. Okay, probably you can hear me. Okay, friends, it's wonderful that you at so early hours find possibility to visit our presentation. You have make this great choice instead to have to sleep another hour or 1.5. Probably I hope it will be very fruitful and interesting presentation for you. Okay, first of all, boundless gratitude for my friend, Joe, a great friend of Ukraine, great friend. The man with great heart and very sharp mind. Joe, thank you. Also, thank you for all your team. You were involved. It was fantastic work. And this cooperation, these fantastic people, lovely people, allow us to speed up and deploy the project in a fantastic timeline, very quick. Okay, so my name is Taras. I am head of the dispatching control system department in Ukrenergo. So Ukrenergo is a Ukrainian TSO, transmission system operator, and we are responsible for dispatching and transfer electricity through high voltage overhead lines from generation plants to customers.
All right, so there's our performance disclaimer. All right, so please continue. I'll just go ahead and advance the slides, manual.
Okay, through all this conference, we had a lot of importance about community, cooperation, collaboration between all cybersecurity professionals. Believe me, this project from different countries. Believe me, this project was exactly about this cooperation. The synergy of these wonderful experts help us, as I mentioned, to in very quick time, very fast implement the project. Also, yesterday we visited a good presentation where Mr. Dave DeWalt mentioned in his opinion about future perspective of future cyber attacks, that the future attacks will also include electronic warfare system using of them. And our project once more time about. Okay, Joe will talk about all these interesting details regarding this project, and I will trying to share you information. What is Ukrenergo? What is challenges did we face before the war? Why the date of the war starting was selected exactly what we have February 24, 2022, and what is the current situation in energy sector and why did the power up project emerge. So, Ukrenergo, as I mentioned, Ukrainian TSO, before the war, before the Great War, after occupation of Crimea in 2 regions of Ukraine, we had more than 20,000 kilometers of overhead lines. We have 110 substations, and with annual generation of over 140 billion kilowatt hours. The energy system of Ukraine was split into two paths. Yeah, one was connected to Russia and Belarus grid. It was mostly 96% with Moldova, and small part, 4%, worked synchronous with European networks. Okay, thank you, John. So it's evident that after aggression of 2014, there was need to cut any ties with Russia, includes first of all of energy sector, as any energy resources from Russia were used like a political pressure tool to achieve their goals. It usually we saw a lot of time during our history. Therefore, in 2017, we started the preparation for integration with European network of TSO, ENTSO-E. Let's go back to the 2021. 4 years of this preparation are behind us, and ahead of us are 2 system stress tests for our energy system, one in winter and one in summer 2022. The scenario of the test involved disconnecting our grid from Russia, Belarus, and European part as well, and together with grid of Moldova, we should conduct this test in isolated mode. The results of this test were expected to give us a green light on our way to integration with European grid. It was a main mandatory must-to-do option. So it's worth emphasizing once more time again that Ukrainian power grid never operate in this isolated mode. It was totally new. We didn't have a proper experience, so it was very stressful preparation and very with high responsibility. My team's task was to prepare all dispatching system to operate in the new mode, implement other solutions to enhance network observability and manageability. Just a month before the test, we completed the implementation of WAM system, which was expected to be one of the key solutions to ensure system stability during this passing isolated mode. We were under preparation, and Russia, unfortunately, too. During 2021, they accommodated their troops near our border with Ukraine, from Belarus and Russia part, realizing that our power grid could be vulnerable. They have idea to make some stress, yeah, and attack exactly in this very tough time. So we have among ourselves, we said it's a full-scale invasion being this week, or it won't happen at all. So it's very important understanding of current situation to understand our background with our system. So we started to think how to migrate part of dispatch center and some part of data center equipment at least for critical systems like a SCADA, like a WAMS, to secure place to the western part of Ukraine. And then comes the day of disconnection on February 23, 2020. Everything went according to the plan. We switched off line by line, and we have disconnected last overhead line at 1:30 a.m. So we have to check what is the behavior of the system, how it proceeds, how it operated in new mode, and when we recognize that everything is fine, we go to sleep. And through several hours, the war has been started, full-scale invasion has begun. Okay, obviously that we cannot follow the previous plan to make some tests and connect back to Russia. It was one-way ticket, so full steam ahead. We passed the tests, and immediately after receiving the results, positive results from our European partners, our top management sent a request for emergency synchronization. So it was totally new for ENTSO-E because it's a huge organization. They're very conservative, very quick, but many thanks for them. Through 3 weeks, we have full connection to European grid. It was March 16. So at the same time, we started to lose our energy objects. We lost a lot of our substations, and what is more crucial is that we lost the biggest nuclear power plant, Zaporizhzhia, in Europe. 6 units, total capacity, installed capacity 6 gigawatt. Also, the out of operation nuclear station Chernobylska was also occupied. And we know, after all, we have information that also they had a plan to capture South nuclear power plant. So here you can see how the war invasion was very good manageable and aligned with this energy situation. Yeah. So the idea was to capture the more powerful generation and make some stress, yeah, for our citizens. Okay, but after our synchronization, after March 2022, it looked like situation in Ukraine was better. So, at June 2022, we starting to export electricity to Europe. So it was a very great achievement, and it helped us to reach a lot of income for our country. Okay. Maybe you can switch to previous slide, number 3. Okay.
Yeah, go back one, sorry.
Okay. What you can see here, however, this is our successful period of while we have possibility and enough capacity of our generation plants to export, to provide enough electricity to export to Europe. We faced with new challenge. It's kinetic attacks. So kinetic attacks, first attack was on October 10, 2022. So Russia launched its first massive missile strikes on our substation. The main target was were our auto transformers. So Russia recognized that it's not it not be able to occupy entire territory of Ukraine. So the main idea was to destroy everything they can reach, to make us more vulnerable. On November 26, we had first and thank God's last at current moment blackout in our grid. So here you can see how our energy object usually look like after missiles or drone attacks. So generation plants, substations, and Kakhovka Dam, which was blew up to block our offensive of Ukrainian army. Totally, from October 2022 to February 2024, there were 16 massive missiles attacks, 18 drones attacks on our facilities. A total of 198 missiles and 60 drones attacked our infrastructure. The consequences were devastating. 47% of our transmission grid were destroyed. 50% of generation capacities were destroyed. Exports were stopped after first attack, October 10. So we were forced to apply schedules of switching off for customers. I need to add that in March 2024, they start new attack, a lot of attacks, again exactly generation, which can provide you spinning reserves, so quick reserves. So several hydro plants, several thermal plants were totally destroyed, and total, for World Bank estimations, the total damage of Ukrainian energy sector, its generation, its transmission, its distribution, estimate is under $11 billion. So about cyber attacks, it's clear that all the time Russia trying to attack, to use all these tools which they have. Russia has experience in successful attack of Ukrainian energy facilities in the past. Let's recall the attacks of 2015 and 2016. So there were expectations of causing significant damage at this stage as well. However, we have some experience, so we were pretty good prepared. Okay, interesting fact that it was expected that after starting full-scale invasion, we have significant increasing of the attack. Yeah, and in future we recognize that quantity of attacks are increasing all the time when they are preparing or do the kinetic attack. So it's usually combined. Our colleagues from Ukrainian CERT yesterday also present this mind, so they can confirm that they have the same conclusions. Okay, so as I mentioned, we implement several effective and useful systems for monitoring and operation of our grid. One of these was WAMPS. Yeah. So very short, the system allow you to gather telemetry information from synchronous phasors with high frequency and have extended understanding of what is going on in your grid. It's very important in case all the time you are losing part of your grid, and you lose this auto transformer, this substation, this generation, and so on. So this is a very powerful tool which allows you to avoid some damage, significant damage, yeah, or you can very quick identify the islanding in your grid and trying to restore it. Okay, so about cyber attacks, more or less we manage with them, yeah. but we need to do something with kinetic ones. So we started to defending ourselves against military threats. That's when our Cisco project began. So, and I think that Joe will start his part of the presentation regarding this impact of electronic warfare system for our grid.
Hello again, friends. I mentioned earlier at the very beginning that I was having dinner with Taras and his colleagues from Ukrenergo. And I'm a grid practitioner. I've been doing cybersecurity and critical infrastructure for a long time. And I was getting a litany of problems, kinetic strikes on their electric grid, cyber attacks that were varying degrees of successful. And sort of sandwiched in between all of those, they go, man, we can't even get reliable GPS. And in the back of my mind, I knew that was important for grid synchronization. Taras mentioned it earlier. And I'm going to run you through a very basic primer of why synchronization matters so much and the feat of what they did when they disconnected from the Russian and Belarusian grids is so wonderfully executed, but so difficult and important to do. Something I want to convey to you on the Ukrainian electric grid saga. Every day is a new day where things are being done that have never been done anywhere else in the world, because war forces you to do these things. If you want to keep civilization functioning, your economy functioning, if you want to protect lives, hospitals can stay on. Even if I can just give somebody 5 more minutes of electricity with their coffee in the morning, how do you put a value on that, right? So when I knew they were having it with the GPS, I listened to all of their issues. The organization I work for inside of Cisco called Talos, we assist them a lot with their cybersecurity gratis, but we also, we have big hearts and we believe in helping people who are down and out. And to Cisco's credit, they give us a tremendous amount of runway to do that. So let's talk about this GPS issue and Project PowerUp. Just a real quick primer for those of you power vocab folks out there, I guess. Synchronization is important for electric grid. It is a ballet. It is a delicate, coordinated dance between multiple people over tens of thousands of kilometers of power line. It's one all massive interconnected system, all right? Shipping power and receiving power must be done between coordinated entities that millions, tens and tens of million people rely on that synchronization so that they can have power, all right? One of the things that we have to measure in very strategic spots is the frequency, something also that Ross mentioned. That's how we understand our synchronization, right? And we have a standard, 50 hertz. So on the left, we see supply and demand are relatively in balance with one another. It's a bit of a careful yoga being done. Well, what happens if demand outstrips supply? Well, Ukrenergo would have some hard decisions to make. They could go, well, we need to spin up more generation, assuming we can do that, right? Assuming that plant's not a crater somewhere. Or we need to reduce demand. So if any of you have lived in the United States and it's a really hot day, you might get an alert from your utility going, hey, we'd like you to cut power between 3 to 7 p.m. That would be reducing demand, or something called demand response. So how do we know what the balance is? GPS, it tells us everything. And for all of us, we use GPS, we use it on our phones, right? Where am I going? What am I doing? If anyone's used GPS and it says that turns in 200 feet to your right, it's typically in 100 feet to your right, so slow down. But we also use it for some other interesting things, right? And it actually goes by the acronym PNT, Precision Navigation and Time. For the US satellite constellations, we've got about 32 satellites in orbit. They have atomic clocks inside of them, nanoseconds of accuracy for accurate time delivery. And we use them all the time, every day, to get around, to know what time of day it is, but we all are on the same clock, and that is important. So something that I had to learn last year was, what is electronic warfare? For any of you signals intelligence or electronic warfare folks or prior service, you know, but for a muggle like me that's a cybersecurity guy, I really didn't know much about it other than it was a thing, right? So I had to get very smart on this, all right? And working with incredibly smart people inside of Cisco and government partners and industry partners, I sort of began to assemble a team. I said, what do you know about electronic warfare? What do you know about the disruption of GPS inside of Ukraine as it affects civilian infrastructure? And the answer was nothing. The fog of war was preventing us really from understanding the scope and the scale. And then we brought Taras from Ukrenergo in and Sergey from Ukrenergo in, and they really began to explain just how vital that is. But ultimately, electronic warfare is this. It is the protection of the electromagnetic spectrum for your military and civilian infrastructure and the denial of that for your adversary. Think radar, think radios, think GPS, of course. These things are vital for you to advance your military and civilian objectives. The opposite is true for your opponent as well, and you're going to fight over these radio waves to basically inflict your will upon your adversary. We can kind of see some portable electronic warfare tanks and equipment that's used. These are actually Russian. The Russian EW game is very, very, very strong. They're very, very good at this. You're probably wondering, well, why GPS? Everyone heard of a coordinate-guided munition? These are ballistic missiles, these are drones. They use GPS to find their targets. You can get a 5-meter bit of accuracy on a coordinate-guided munition. 5 meters is very, very accurate, right? So I'm able to target individual transformers and substations that are effectively irreplaceable. I'm able to target specific generation plants and know that I'm going to have good effect on target when I launch a kinetic strike against that. GPS, though, we've been using it for so long. It's really old technology, guys. We launched our first GPS satellites in the 60s. As you know, I'm an old man, so I remember the life before GPS where you had to read maps to get to where you wanted to go, and then we had MapQuest, and then now we have our iPhones with our sensitive GPS receivers on it. Those are hypersensitive GPS receivers on our phones, and I can tell you that because GPS is an incredibly weak signal. We're talking medium Earth orbit. We're talking, it is the collective energy of a light bulb 10,000 miles away from you, a 50-watt bulb. All right. When you realize, as I've discovered, that GPS is that weak of a signal, it is incredibly easy to just push over and go, you don't get it. All right, you don't get it. It's cheap, it's effective, it's accurate, which is why a lot of coordinate-guided munitions use it. They have other backup systems as well, but GPS is a no-brainer. In the civilian world, it's also the same. It's a hockey puck with a cable that sits in your electric substation or your hospital or wherever you need accurate precision time, and I could go to Radio Shack or Best Buy, probably find one or something. It's commoditized, it's easy, it's cheap. Sure, let's use it. It's also incredibly fragile. All right. If you're in a concrete building, or if you're in a bunker, or if you're someplace where you're going to have things interfering with radio signals, GPS is typically the first casualty. So I need to talk about why GPS is so important to the electric grid. I want you to go back to high school or elementary school. Everyone knows what a marching band is or has seen a parade in their life. And it is a coordinated step march while everyone's playing their musical instruments. Now take that marching band and I want you to make it 25,000 kilometers long. All right, the back cannot see the front, you're over the horizon. These sort of are the electrons on this spider web of an electric grid that goes all over a country the size of Ukraine, which is second largest in Europe. They operate at kilovolts that are way higher than most of Europe. They have to push power very far for their population, right? Well, how do we measure that marching band and know they're all stepping at the same time? We could use a clock, right? Well, what if I have a clock that's 5 seconds ahead of yours? And what if he has one that's 30 seconds ahead of mine? Well, we're not going to be in sync, are we? All right? To us, it's going to look like we're doing just fine. In reality, we're not. For electric grids, this is awful, all right? This can push supply and demand into places where I cannot actively measure it. And what we use that time, that T and P&T, is for data timestamps. We measure power every 30 microseconds. So we know what the frequency is. It gets an accurate timestamp. It's delivered to the dispatch center super fast, and your dispatch operators get an instant health check of what the frequency is in the grid and are we synchronized. When you lose that clock, when you lose the ability to timestamp yourself, you are really in a bad spot. I'll ask you this, you're out of synchronization, you don't know why. Did something blow up? Right? Did I just lose something? Was there an equipment failure? There could be lots of reasons. Bad weather, things like that. Natural disasters happen all over the world. Now, here's the slightly disconcerting part. What they do in Ukraine is used all over the world. There's not an electric utility in the world that's not using GPS to synchronize their electric grid. But war changes you. It changes how you have to operate. So this is the basics of how it works over there. We receive GPS broadcasts from orbit. Something called a Grandmaster Clock, or a GMC, interprets those signals, converts that radio signal into a digital signal, which then feeds into metering power equipment in these substations that timestamps the frequency that they're measuring, sends it right on to the dispatch center. All is well with the world. When that's taken away from you, the actual power equipment has no idea what to do with itself. It doesn't know. It has never operated in a world where GPS is being taken away from it. And that's not the fault of the WAMS system or the vendor. Who designs this equipment to operate in a war zone? The answer is no one. Really no one. You can build ruggedness and reliability into your equipment, and you have to, because these operate, and not data center friendly places. So temperature and moisture and things like that. But how about vibration, because an artillery shell exploded 10 meters from you? All right? Yeah, no, that's probably a bit outside of the design of what this equipment was meant to handle. So when things panic, here's a nice little screenshot of that. You will see the dreaded synchronization is lost. GPS signal has been scrammed, and the system just doesn't know what to do with that data. So it throws its hands up in the air and goes, I'm just not going to do this anymore. I'm out. That was when I stepped in and went, you know what? I think we can figure this out, but I'm going to need to put a team together to do this. And we had two imperatives. We got to move fast because people's lives are at stake while we think about this and noodle on the problem. Perfect is the enemy of good enough. I originally wanted to get atomic clocks and shipped them to Ukraine, but they're $30,000 to $40,000 a piece, and they would need quite a few of them, and I'm not that rich. I remember at dinner, they were like, "You're going to cut us a check?" And I went, "No, sorry guys, I can't really do that. Not unless you take pesos or something, I don't know." So we had to get smart at Cisco. We made our own internal jamming test rig, not using radio waves, because the FCC would not like that. But we basically said, I wonder if we can simulate battlefield conditions enough to test what we think would work on a piece of equipment we call the Industrial Ethernet 5000 switch. It is a ruggedized little pizza box that sits in substations and factories and just helps facilitate network communications. But here's the really cool thing about it. It's got a clock inside of it. It's not an atomic clock, but it is a ruggedized crystal oscillator that you can pass an electric signal through, and it will do microseconds of accuracy, right? I had full Cisco business unit buy-in. I had executive leadership going, do you think this is going to work? And I went, I think we can make this work. We would end up working with Ukrnergo across the pond, and we would end up modifying the firmware inside of these devices, which is no easy feat for an 80,000 person company. And we would basically create what we call a holdover. A holdover is super basic, super simple. Basically, when the satellites go away because of electronic warfare, now that could be the Ukrainian military doing it or the Russian military doing it for whatever reasons, we step in with our little pizza box, our switch, and we go, no, 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 please do not panic. We are synchronized with that satellite when it went away. We're going to hold the clock for you, all right? For about 2 to 4 hours. We can actually do it a little bit longer, actually do it a lot longer, right? Then we trick the power equipment in a way, if you will, with the right metadata messages for something called precision time protocol, and say, we're going to keep the time for you. The power equipment is cool with it. They go, oh, sure, you've got the time, no problem, all right? So we've installed a secondary oscillator into their substations that operates in the absence of GPS. And when the satellite signal eventually returns, it's slow because, again, we're talking about older technology here, we gracefully pass off back to the satellites. And this might happen 5 to 6 times a day. It really depends on the cadence of the kinetic strikes that are happening in Ukraine on any given day. And if you've been following the news lately, it's been pretty bad. So when we got our prototypes made, we had a couple prototypes we need to get into Ukraine. Has anyone here how to mail something to a war zone? If you know, now's the time to tell me because I'm going to be really angry. I'll talk to you later. Well, our friends in the government stepped up and said, hey, look, there's a humanitarian aid shipment leaving. If you can get us these prototypes, we can get them into Ukraine within a week. And the U.S. Air Force stepped in and did us a real solid, and we got our 2 switches, which you can kind of see on the top a little bit, on a C-5 transport leaving out of the United States. It went to Ukraine, went to Poland, and then to Ukraine. And I think one of the best days of my life was when Dima and Taras, reported back with a little bit of little back and forth troubleshooting that I think they just pulled the cable, the GPS cable out of the system, out of our secondary oscillator, and it says synchronization maintained. Folks, that's a touchdown. That's success. That's what it looks like when you can rapidly innovate and, not to be too fine a point, literally build a bridge, all right? Then we would go through some humanitarian aid assistance inside of Cisco, and I would get a lot of these made within a week and shipped to Europe, and then they would eventually wind up inside of Ukraine. Some other problems we're confronting right now is also something called spoofing. Basically, these substations don't like thinking they're 10 miles underground. Spoofing is the deliberate misrepresentation of location for GPS. This one says it's in Moscow, not great. That disrupts the power equipment, but we're working on that right now. It's just a much harder problem to solve because this satellite constellation that we use is always in motion. It's got a little bit of flexibility built into how it communicates with receivers. So it's a harder problem to solve, but we're working very hard on it. And this is something that I want everyone to be aware of. In the United States, we really don't have this threat. But if you're in the Asia Pacific or if you're in Europe, you no longer have the luxury of a reliable EMS system if another country, through its foreign policy apparatuses, decide that you no longer get to have it for whatever reason. It is a shared space of all humankind. This happened in December 25th of last year when a third of Poland lost access to GPS. We suspect from Belarus, but we don't know for sure exactly. It's kind of tough to pinpoint those sometimes. But for reasons I'll never know. Reasons I'll never know. We live in a different world right now, all right? The Ukrainian war has just very boldly expressed that. So it's important you understand the critical infrastructure impacts, all right? If you're wondering, if you have a new look at life on GPS, welcome to my world. The thing you rely on is incredibly fragile. The thing we as a civilization rely on is incredibly fragile. One of the things I did when I built this team of people, and it ended up being about 40 of us, multinational, multi-company team across, on the other sides of the planet working with each other, is that we all had big hearts. We said, this Ukraine war is crap. These are people that we love, that we respect. They are friends, and they have families, and their families and friends. And in my organization alone, of the 500 of us, 80 are Ukrainian. And these are people I get to work with and that I love and respect, and they're fantastic. I want them to be safe. I want their families to be safe. I want them to have reliable power. If I can give a child 5 more minutes of their childhood watching cartoons because the power stays on, worth it. If a hospital doesn't have to worry about its petrol generators, whether or not they're going to work because power for some reason is lost, because supply is diminished for whatever reason, worth it. Worth it. You cannot put a value on reliable power when people are shooting at you. That's just the hard reality of our world. And that's basically something that I just wanted to convey to everyone here. Lead with your hearts. You might be at dinner one night with someone in a hard spot, and you may not have any answers. But in the back of your mind, with a big heart, you go, maybe I can do something, or I know someone who can help you. That's all I ask for anyone when you walk out of this talk, all right? Just think with your hearts. Before I end things, I want to give Taras the last word. He flew over here at no personal risk to himself. The Ukraine is in a bad spot right now. They're doing really great. They're rugged, resilient, stoic people, if there ever was one on this planet. And it is important that we did this for Ukraine. So, Taras, would you give us kind of your final thoughts, please?
Cool, thank you. Really, we were very lucky with this project, with this meeting, and with future results. So, colleagues, many thanks for your interest for our project, for our situation in our energy sector in Ukraine, in all Ukraine. Your support, your attention, it's something which can give you some faith that we can fight, that we are not alone, and we will be able to win. Many thanks for you. Stand with Ukraine. Slava Ukraini.
Gheroyam Slava.
Thank you.
Wow, we did that in time. Polished machines, my friend.
How's it going? Quick question. So you were able to come up with a kind of a solution for the GPS timing problem within the power grid. Have you tried using or seen a similar effect with, like, say, cellular communication networks?
It operates in the electromagnetic spectrum as well. One of the issues, so we looked at NTP, we looked at other ways to think about, ways to wirelessly get and to do that. PTP works in microseconds, something like NTP works in milliseconds. It's just too slow, unfortunately. It would have been great if we could have used it though. But you will find that cellular networks use GPS timing as well, which is not a great feeling to have when you have all these cellular towers and you're like, well, I hope they have access to it as well. I think it's a little less disruptive to them, knock on wood, I could be wrong. But great question, yeah. Yes,
We
ma'am.
can maybe add to regarding the synchro phasors, regarding the standard CS7.118 requires time accuracy less than deviation less than 31 microsecond. So, and to build some distribution system of this time, PTP version 2 power profile, you need to have your architecture, your grid, which in all this device through the road, which are transparent for this protocol. When you have part of your lease lines from operators, they cannot guarantee that you have this option. So why we have this on each substation, we have these clocks, and we should solve this problem. Probably in other situation with other infrastructure, architecture of infrastructure, the situation can be different, but anyway, now we're in the situation.
Keep in mind this is being sampled all over Ukraine where the nearest substation might be 400 kilometers away from the other substation. So it's a very difficult engineering challenge. Yes, ma'am.
Hi, thank you. My name is Alex. I'm an IT engineer at Google. This is something I don't know anything about, so forgive me if my question is a little bit basic, but can you talk a little bit more about how the capture of the dam in, I believe, Kakhovka, was it?
Kakhovka.
And then destroyed, can you talk a little bit about how that impacted your operations? Thanks.
Yeah. Okay. What is important to mark here is that all our history, our grid, we are operating in parallel mode. So Russians has information about our grid, all technical, what kind of auto transformers, how current situation, telemetry. They receive telemetry, so they understand what is what. And they have this plan how to attack. The main idea was to scare our government, have very quick force trying to capture Kyiv and capture all the high capacity generations, So Kakhovka was captured very quick in several hours. So they stopped generate, yes, we switch off, and it's all. So we totally lose control under the station. So you have this possibility. It's like you have several power banks in your flat, in your house, and one of them you lose. It's works.
The end result could be that loss of generation means they also have to reduce demand to avoid blackouts, to avoid equipment tripping out to protect itself. Generation is irreplaceable. It really is.
And very important that hydro plants, they are controlling by application AGC. It's part of SCADA, automatic generation control. So some system which can understand what you have the situation in your grid, what frequency, and have decision, do you need to decrease or increase generation? And hydro plants, they are very fast reserve. So if you have some imbalance in your grid, you can very quick automatically shade it. And if you lose this possibility, you don't have this tool.
Yeah. We have 5 minutes left. Yes, sir.
5 minutes. Is that going to be enough? I have so many questions. Slava Rukani, what do you look at for redundancy? I was going to ask about NTP, but you answered that. But there are other satellite systems besides the U.S. GPS system, right? And are
I can
those
take that,
usable?
yeah.
Can you have more than one source than just this one pizza box, so that, you know, with other synchronization, you can't just rely on one thing. You found out what happens when you do that.
So I can take that. That is a question I'm working on right now. So you have L5, which is going to be the new generation 2 of GPS. They haven't deployed all the satellites yet, though. It turns out launching a satellite to space is really expensive and time consuming, and there's a long window for that. You have other constellations like Baidu, Galileo if you're European. They're not going to use GLONASS. I'll just tell you that right now.
Why not?
Yeah, I know. That's just, I don't know why I would use Russian satellites.
They use GPS.
It's jammed by design.
Yeah, it's just like, they go, no. The fundamental problem you're going to have with any, and this is on the L1 band or L2 band, is that all those constellations are in roughly the same orbit size, except L5, which is closer, it's near Earth orbit, which does have a stronger signal, which is more difficult to jam, but it's not foolproof. Here's the reality that I've come to accept about anything in orbit. I don't control it. All right, I have no say over that satellite, where it sits, and the strength of its signal. So yes, switching to Iridium or another satellite constellation might be better for you. Probably should do it because it's just more difficult to knock over, but it's not a sure bet. You know, war could break out and they start shooting down satellites, God forbid. Secondary oscillator combined with a more resilient radio EMS protection, I think, is probably the future of what we're looking at right now. We're making it up as we go. So
Other terrestrial backups?
they all rely on,
Okay.
yeah, satellites. It's cheap, it's easy, so yeah.
All right. Nobody else waiting in line. I'm going to go a completely different direction. How do you remediate intrusions? It's not all denial of service. They're going to get into your system. How do you get them out quickly, reliably, knowing that you got them out? You've got more practice at that than anybody else. So, I mean, I'm the local power company. We don't have to deal with what you deal with, I hope. But we want to be ready in case we ever do. So what's the best, you know, what are some lessons that you would give us for
Lessons.
remediation when they get into your systems?
Thank you. Very good question. So, the first, you must recognize that each system which you are responsible for, you can lose, and you will lose it. Believe me, you will lose it. So, we faced with very interesting situations that when the invasion has been started on the eastern part, we're starting to switch off from our network, IT network, OT network, our substation to avoid direct attacks. Yeah, if we afraid that somebody connect a lot of equipment and attack our grid. Yeah. So what we faced with other situation, we lost a lot of telemetry because a lot of bridges were blown up, exposed, and all these lines, leased line or our lines, communication lines, yeah, channels, was destroyed. So we're starting to lose part of on the map telemetry. So now we have other solution, very flexible, to provide us possibility to gather telemetry from the substation.
Yeah, and unfortunately we're out of time. That's our last question, but a great question. We'll be outside in the hallway to talk if any of you folks want to just,
We can continue
chat.
because it's really very long.
It's a long answer, a
a
long
lot
question.
of lessons.
Yeah.
A lot of lessons.
Thank you so much for being here, everybody.
Thank you.
Yeah.